Hi everybody, welcome to another video in Calculus 1, section 2.4, infinite limits. This section and the next section we study about infinite limits and limit at infinity. So the difference between the two is that limit at infinity is limit of the function where x approaching to plus or minus infinity, whereas infinite limits is where x approaching to a constant. And that could be either go to a from the left hand side, or go to a from the right hand side, or just go to a in general. And as x go to a constant from both sides, or from the left or from the right, the limit does not exist. It does not exist because the values go to infinity like that. So here we have infinite limits, and here we have limit at infinity. So those are different scenarios. So first, let's find the limit of 1 over x squared for that function, 1 over x squared. So I will graph y 1 divided by x squared, or if you want fraction, alpha alpha y equal to that fraction 1 over x squared. And the graph look like that. If it's not very clear and we want to zoom, we will hit zoom, and then we can choose this option, or we can hit Windows and we can change the values of x and y as we want to. By default, this is the default values. Windows, that default, you can change any of this. If you want to, we can change any of this. Or zoom, I would choose zoom box. Zoom box is just like when we have a mouse, a computer mouse, that is. We just select, hit enter for the top left, and then one more time for the bottom right. So we zoom that window, zoom in that window, and that's what we have. Right? If we want to go back to the original window, original values, hit zoom number 6. That's the standard window. Right? But either way, if we see when x gets closer and closer to 0, it goes to infinity. If we want to be more precise, when x goes to 0 from the left hand side, it goes to infinity. And when it goes from the right hand side, it is also infinity. Since the left hand side and right hand side, the values are the same. However, infinity is not exactly equal to infinity, because infinity is not a defined number. It is more like a concept. So in that case, even though we say the limit go to infinity, but we also say that the infinite limit does not exist. Or we can also say does not exist because infinity is not a number. It's not a defined number. Alright, infinite limits. Now we focus on the infinite limit. What happens when x go to a constant? The values will go to something that is undefined. Alright, suppose the function is defined near x, for all x near a. Again, with the concept, the idea of limit doesn't have to be defined at a. The function grow arbitrarily large for an x sufficiently close to a, then we write this. So that is kind of with the idea of the limit, and we write the definition. So it's The idea is where x sufficiently close to a constant a and the function grow arbitrarily large. That's where we say the limit go to infinity. And the same way we can define for the limit where the function go to negative infinity. And it is, we say that in both cases the limit does not exist. Once again, infinity is not a number. But in interest of the calculation, if we can specify if it is infinity or negative infinity, we do so. Unless it does not exist, then we say the limit does not exist. For now, we just based on the graph, look at the graph and we can say the limit. So what is the limit when for this function, when x go to 1, x go to 1, the y go to infinity. So by looking at the graph, we can tell this go to infinity, and when x go to negative 1, it go to negative infinity. So just by graphically, we can determine if it is infinity or negative infinity. Of course, when we have something that go like this, on one side it go to infinity and one on the other side go to negative infinity. So this one definitely does not exist. So we write infinity or negative infinity or does not exist to distinguish the scenarios of those three cases. Could go, both of them go to infinity, both of them go to negative infinity, or one infinity, one negative infinity. In this case, this does not exist. Right. So sometimes we want to be more precise to distinguish those three cases. Right. Now, suppose a function defined for if f of x become arbitrarily large for all x close to a with x greater than a. So in this definition, we define the infinite limit, but for one-sided. So we have 8 negative from the left or from the right. So this is infinite limit for one-sided, or to say one-sided infinite limit. So we define on one side only. Right. Now, what do we put a note here? Okay, if we have the graph and it looks clear enough like this, and we can tell if we want to do numerically or algebraically, how do we do that? So it is just a review what we have earlier. Remember in section 2.3 we say that 0 divided by something else is equal to 0. Right? Now, if we have 0 divided by 0, it is indeterminate. Right? And the last case is what happens if we have something other than 0 divided by 0. Earlier we say that this is undefined, right? It's not wrong. But in some case, this can also be, I can't believe this. Anyway, doesn't matter. That's not wrong. But in this case, we will elaborate a little more. If we have something small, I think if we have something not equal to 0, divide by something that go to 0. So now we focus on something that is not equal to 0, but we divide by something that approaching to 0. In that case, this will be equal to plus or minus infinity. Now this is the new thing compared to what we have earlier. Those two are exactly, are not different. It's undefined. This one plus or minus infinity is considered does not exist or undefined. Anyway, so think about the function 1 over x squared, right? So, by the way, if you want to, we enter this in y1. If we want to evaluate the function at y1, for instance, I hit alpha, trace, and y1. If your calculator doesn't have the bottom menu like this, try hit variables, y variables, function, that's y1. Now if we put a number that is close to 0, like 0.1, and then 0.001, we go back to this. If we have a finite number, like for example 1, the smaller we have at the quotient, and the smaller number we have at the denominator, the bigger the quotient. If we have 1, divide by 100, it is very small. Divide by 1, it is bigger. Divide by 0.0001, it's even bigger. So the smaller number we divide by at the denominator, where the numerator is constant, is going to be bigger. So essentially, if it goes to 0, it could go to either positive or negative infinity, depends on whether it positive or negative, depends on what we have on the top as well. Because after all, positive divided by positive is positive. If they have the same sign, will be positive. If they have opposite sign, negative. But if the top is not 0, the bottom goes to 0, then that will be plus or minus infinity. So mathematically, that's what we're going to use in this section. The infinite limit involves this case. Right. Next we have, we define vertical symptoms. Vertical symptoms, if the limit of the function go to either positive or negative infinity, either on the left side, the right side, or on both sides, then we say x equal to that constant a is the vertical symptom. So we only need one side the limit, we don't need both. If one side, the limit from one side of the function goes to infinity or negative infinity, then we say that is the vertical symptom. X equal to that number is the vertical symptom. Right. Now take a look at this example. Consider the graph of the following function. Now find the following limits. Right, we have the graph. Now later on we have a lot of examples where we do this numerically or at least algebraically. But for now, just do that graphically. So if we have this graph, what is the limit of the function where x goes to 1? When x goes to 1, the function goes to infinity, right? That's easy enough. Next, what is the limit when x goes to 3? This is 3. But from the left hand side, so from the left side, it goes to negative infinity, and on the right side, it goes to positive infinity. because of that, the question did not ask us, but because of this, we can say limit of the function as x equal to 3 does not exist. This one we know for sure it does not exist, and not infinity or negative infinity. But regardless of the limit does not exist, one of this is enough to say that x equal to 3 is a vertical symptom. The vertical symptom only need to have one side. We can define just based on the one-sided limit. So in this case, we have two asymptotes of x equal to 3 and x equal to 1. Both of them are vertical symptoms. Right. Like I said, in this case, we only do based on the graph. Now, what if we want to do it numerically? What do we do? Well, remember section 2.3, previous section, when we're trying to find the limit, put in the numbers and see what happened, right? And remember, when we put in the number, I don't put in the whole fraction, just put in the number on the top, a number at the bottom, and see what happened. Now let's just exactly do that. I'm just going to do for x equal to 1, so you get the idea. If we want to do this sort of numerically, so what I do is I'm going to put 1 on the top, 1 at the bottom, see what happened. Right. So in that case, I would just say 1. You see the SDO key here, store into x. Now x will have the values of 1. Then I would just enter the function alpha y equal to. On the top I have x minus 1. X minus 2, sorry. I mean, we just, like I said, don't enter the whole thing, just enter the top and then the bottom. X minus 2. That gives us negative 1. And then the bottom, x minus 1 square. Of course, the top looks silly, but you'll see why we have to do that. X minus 3. So when x equal to 1, x minus 1 square times x minus 3 is equal to 0. So of course, usually in this case we say it does not exist, right? Because we have negative 1 divided by 0. It does not exist. But now when it is the case, we take a step further and let's say what happened if it is from the left hand side of 1. So in that case, what could we change? Right. So when x go to 1 from the left hand side, the top, if it is not equal to 0, we don't care about that. The problem here is when we have 0, it could be from the left side of 0, which is negative, and on the right side of 0 would be negative. So we only do that when we have 0. Once again, the one-sided limit, especially in the case when it's equal to 0, we have to pay attention to that, because on the left side of 0 it could be negative, on the right side of 0 it could be negative, so we don't know. So in that case, what I do is I will take a number that is on the left side of 1, so you can choose like 0.999 and store into x. And then evaluate that again. We have a negative number. So from the left hand side, we have a negative number. And negative divided by negative is positive. Right. So that's why, like I said, when we divide by 0, we have to be mindful as if it is negative or positive. Because the negative 1, if it is not 0, we don't really worry about that. only worry about it when it is 0. So we did one of them. What happened if we have now? What happened if we have a plus sign? Well, if it is the plus sign, we will have still -1 on the top though. That doesn't change. We're going to choose the number on the right side of 1. Like that we do. Start to x. And evaluate that. We have also negative. Yeah. By the way, that is 1.999 times 10 to the -8. So this is extremely close to 0. But like I said, I'm only focused on the negative here. The e here meaning times 10 this to the -8. So that's why it's extremely small. But it's still negative. So negative divided by negative is positive. So that's why both of them go to infinity and that one go to infinity. So we sort of do this numerically. If it is something else, we're not worried about that. If it is 0, we have to know if it is negative or positive. If you don't want to write the 0, -0 like that, that doesn't make any sense. You might want to write 0 like that. Either way, we understand what we mean by that. Right? So, when trying to find the limit of the function, an infinite limit, just put in the values for the top at the bottom. And then if it is equal to 0, let's check. Is that negative or positive? Because if they have the same sign, it's positive infinity. If they have opposite sign, negative infinity. Right, let's look at this example. We have a lot of this example. Right, limit as x equal to 0 of x plus 5 over x. So of course we put in the numbers, right? Put in 0. And of course that is 5 and the bottom 0. Now, this is undefined for sure. But if we want to be more specific, if it is negative infinity or positive infinity, now look at when it approaching to x. I mean when x approaching to 0 from the left hand side. So if we use that instead, the top is still 5. By the way, if it is 0, if it is something else, that does not change. But if it go from negative, it's going to be negative. And positive divided by negative is negative infinity. So the limit is negative infinity. Right. Similarly, this one, put in the number for x on the top, on the bottom, 5 over 0. If it's not 0, doesn't matter. But if it is 0, then we need to know, especially when it is one-sided limit. Even though if it is not one-sided limit, we consider one-sided limit to see what happened on either side, on each side. Here we specifically have one-sided limit, so we have to consider that for sure. So if we use that, of course, at the top still 5, but the bottom, if it's on the right side, it's going to be positive. And positive divided by positive is positive. Yeah. Like I said, you can write 0 plus sign from the right side and 0 from the negatives from the left side if you want to. Right, a little more complicated here. How about this? Limit as x go to 3 from the left side of 2 minus 5x. Again, just put in a number. Just a number first. We'll worry about the one-sided limit later. Right. 2 minus 15 is minus 13. 3 minus 3 is 0. If it's not 0, don't care about that. If it is 0, then we need to worry about if it is positive or negative. Now this is negative from that. Now, if that is the case, would we have a positive number or negative number? Right. Now let's do that by hand first. X go to 3 from the left hand side, meaning that x less than 3, right? Right. Now if we subtract 3 on both sides, we have x minus 3 less than 0. So we have x minus 3 at the bottom here. It's going to be less than 0. But we don't have to do that. We don't need to. Right. Usually if we have a calculator, we say the number from the left side of 3, right? 3 with a superscript negative. I just say 3. If it is on the left side, it is a little bit less than 3. So I just subtract a very small number like that and store into x. And I will just evaluate the function. It is negative. And negative divided by negative is positive. So the limit as x go to 3 from the negative side, from the left side, is equal to infinity. Of course, we can confirm by the graph. Two minus 5x over x minus 3. And on the left side of 3, it goes to infinity. Yeah, this is x equal to 3. We cannot really graph x equal to 3 because it's not a function, but the graph confirms it. Right, more example here. Limit as x go to negative 4 from the right side of that function. Right, now this definitely we have to use a calculator. I mean, we don't have to, but it would be nice if we use that. So x go to 4, negative 4. So first I'll take negative 4, store into x. Right, so now x takes the values of negative 4. Later on we can consider a number on the right hand side later, but for now just put negative 4 there. Alright, negative x cubed, I can just say it, that is x cubed 5x squared minus 6x. So if I put negative 4 into x and evaluate the top, I have 168. And notice I don't write the e equal in any of this. Because I'm not sure what is that equal to. Next, how about negative x cubed minus 4x squared? That is 0. Then that's what we have to worry about. Now, the limit is approaching to negative 4 from the right hand side. So what number should we store into x? Right. Don't think about is that negative 4.001 or negative 3.999. It doesn't matter. It is from the right side of negative 4, right? So we have negative 4. It's on the right side, so it's going to be a little bit bigger than that. So I add a very small number like this. that definitely will be on the right side of negative 4, right? I'll store that into x. And we go back and evaluate the denominator. It is negative. Positive divided by negative is negative infinity. Yeah, the reason I don't want to write this equal sign here, because mathematically write like this is not perfectly correct. So that's why I'm not make it equal to. So easy enough, right? More examples. Find limit of this function when theta go to 0 from the right hand side. Right. By default is in the radian mode, so make sure the calculator is in radian mode. Hit mode, radian. Right. Now, problem here is we don't have fraction, right? So we don't have a fraction. We write cotangent as a fraction. Cotangent is cosine over sine. By the way, we will spend some class time reviewing some basic trigonometry identities. We're not going to need all of the trigonometry. Of course, the more we know, the better. But to get to actually success in calculus, you don't need, just need a few of the trigonometry in Cal 1. Of course, the more we know, the better. But the bare minimum, of course, we need to know some of it. Right, so put in 0, what happened? Cosine of 0 is 1. And sine of 0 is 0. Yeah. Now, if it is 1, don't worry about that. Let me be more precise when we talk about don't worry about this. Of course, if we only worry about that if we have something other than 0 divided by 0. Only worry about this case here. If we have 0 divided by something else, that definitely going to be 0. There's no, we not even consider the left side or the right side. If we have 0 divided by something else, that is 0. That one is clear. That one is definitely clear. The one that is not very clear is we have to consider the number and see if it is positive or negative. So here we don't know if it is positive or negative. That's why we have to check in this case. The other cases, the other two cases are clear. Those two are kind of the same thing, right? So if we put in the numbers, and we have 0 on the top and something else at the bottom, don't bother. That's going to be 0. There's no question. But if we have something else other than 0 divided by 0, that's where we have to check and see what happens when to go to a number. Now, if we go from 0 from the plus side, that is easy. We can just say it's 0.0001. Close enough. Good enough. Start to x. And then what is sign of that values? It is positive. Positive divided by positive is positive. So limit as x goes to, there's no x here, right? There's theta. From the right hand side of cotangent equal to infinity. Right. Now, let's do a different example. Let's say what is the limit of theta goes to 0 for tangent of theta. Yeah, but let's say from the left hand side then, doesn't matter. And tangent, if we want to rewrite that as a fraction, tangent is sine over cosine. And then we put in 0. Sine of 0 is 0. Cosine of 0 is equal to 1. Now we have 0 divided by something else. This is not what we have here. When we have divided by 0, we have to worry about that, where there is positive or negative. But if we have 0 divided by something else, that is equal to 0, and we make that equal to. In this case, from the left hand side or the right hand side, it doesn't matter, because we have 0 divided by something else. Right. So that is the difference between those two cases. When we have something else divided by 0, then we have to worry about if it is positive or negative, especially on the one-sided limit. If it is, even though the question did not ask for the one-sided limit, like this one, we have to consider the one-sided limit to see what happened. Is that on the left side of 0 or the right side of 0? Right. So that's what we have. Next, limit that when theta go to pi over 2 from the left hand side. Now I need to write secant as a ratio. Secant is 1 over cosine, right? So we have 1 on the top, that's easy. Cosine of pi over 2, that is 0. Right. Now, we need to know what happened if it go from the left side of pi over 2. So what number do we choose for the left side pi over 2? Right. So we start with pi over 2, right? If it is from the left side of pi over 2, it means we have a number that is smaller than pi over 2. So I will subtract a very small number. Yeah. At about 340, because pi over 2 is a very small number already. So you want to be relative. You want this number a lot smaller than the actual numbers here. So let's store that into x. And now cosine of x, it is positive. Positive divided by positive is positive. So the limit as theta goes to pi over 2 of secant theta is equal to positive infinity. Right. More samples. Let's say we have that function. Now evaluate the limits, these limits, and find the vertical asymptotes. Right. We see that if we have the limits of the function equal to infinity or negative infinity, then x equal to whatever the values is, this is the vertical asymptote. Whether it is one-sided or two-sided limit, it doesn't matter. If we have infinite limit, then there's a vertical asymptote for sure. Right. Now let's find this limit. Right. First thing, always put in numbers. See what happened. Put in 1. That is 1 plus 3 is 4, minus 4 is 0. 1 minus 1 is 0. Now, if we have 0 divided by anything else, that is 0. There's no question about that. 0 divided by 0, that is indeterminate. Which means it could be anything. So I have two factors because both of them have 0 and quadratic. If a quadratic function equal to 0, there should be a factor. And furthermore, the factor is whatever the values we substitute in for x. So both of them should have x minus 1 in it. Determine the rest should be simple. To get x squared, we need an x. To get 3, we need a negative 3. To get x squared, we have x. To get negative 1, we need plus 1. So cancel the x minus 1. We have x minus 3 and x plus 1. Now put 1 in for x and see what happened. 1 minus 3. 1 plus 1. It is minus 1. So define number. So we make the limit equal to that. Right. So here we see 3 clear scenarios. 0 divided by anything else is 0. 0 divided by 0 is indeterminate, and we have to do that. And when we have something divided by 0, we need to know if it is positive or negative, so we can determine if it is infinity or negative infinity. Right, clear enough. Try this again. Put negative 1 into x. Right, negative 1 squared is 1. 1 plus 3 is 4. Plus another 4 is 8. The bottom is 0. Of course, we can just do this with a calculator. Negative 1 is turned to x. And then x squared minus 4x plus 3 is 8. X squared minus 1, 0. Right. Now this from the left side of negative 1. So is that negative 0.9999 or negative 1.0001? So it's on the left side of negative 1. So this should be negative 1.0001. We don't even need to worry about that. We just say it is negative 1, right? And it is from the left. So I will subtract a very small number, and that will be x. And we just need to evaluate the term that question here is the 0. So I will evaluate x squared minus 1 only. Don't need to worry about the 8 on the top. So that is positive. Right. So if it goes from the negative, from the left side, this is going to be positive. Positive divided by positive is positive. So limit when x go to negative 1 from the left hand side of the function is equal to positive infinity. Right, now we do this pretty much the same thing. Put negative 1 on the top. The top still 8. But but this time it is from the plus sign. Now, from the plus sign, from the right side of -1, I will add a very small number to it, so it will be on the right side of -1. And then evaluate x squared minus 1. It is negative. Wait. Yeah. That's correct. It's negative. Yeah, the A is still 8. The only thing that makes drastic changes when we have something that go to 0. Because if it's negative, positive divided by negative is negative infinity. So that's what we have. So when x go to -1, from the right hand side, the function go to negative infinity. Right, this question also asks us what are the asymptotes. So in this case we have to find the asymptotes, the vertical asymptote. So the vertical asymptote it is either whether it's one-sided limit or two-sided limit, it doesn't matter. If we have infinite limit, x equal to that number is going to be the vertical asymptote. So in this case we have x equal to -1 is the vertical asymptote. There's only one. Or is a vertical asymptote. There's only one though. So then you say, what happened at x equal to 1? Clearly, it is divided by 0 is undefined, right? And you are correct. This is not the vertical asymptote though, but it is something that we need to worry about. So, vertical asymptote. Now, what happened at 1? So in this case, we said at, I want to note, so at x equal to 1, we have top, bottom, both of them equal to 0. The limit exists, but the function is undefined, meaning that we have something like this, right? The limit exists because both sides it goes to the same number, although the function is undefined. So when x equal to 1, we say the graph has a hole at x equal to 1. Has a hole. And when we say a hole, meaning that limit exists, functions undefined. That is a hole. Right. That's essentially what we have here. If we have four rational function, if top and bottom equal, both of them equal to 0, then there's a hole on the graph. So what I say here is essentially after all of this we say vertical asymptote occur. So I say for rational function. Could be more than just rational function. Anything that have in the quotient form, the vertical asymptote. occurs when the top is not equal to 0 and the bottom is 0. Right. Home occur when both of them equal to 0. Right. So that's what the last note I want to talk about. The vertical symptom. Maybe a home. Right, let's look at the graph for this one to confirm that's exactly what we have. So on the top we have x squared minus 4x plus 3. The bottom we have x squared minus 1. So that's what we have. Right, the vertical symptom at x equal to -1 here, right? And at x equal to 3, x equal to 1, yeah, the calculator did not show there's the hole on the graph, but we know that there is one. Yeah. So if we're going to graph this by hand, I'm going to sketch this real quick. -1 is the vertical symptom. There's a hole here. Yeah, just a sketch. I didn't do a very good job of it, but emphasize there's a hole here and there's a vertical symptom there. Right. So, bottom line in this section, furthermore, we consider the different cases. 0 divided by anything else is going to be 0. There's no confusing about that. 0 divided by 0, that indeterminate. We took care of that in the previous section. And now when we have something else divided by 0, we have to consider one-sided limit to see if it is positive or negative. Because on 0 from the left side, from the right side, it makes a difference. So it could be either positive or negative infinity. And I think we did quite a few examples about that. And finally, when we have the limit of the function equal to infinity, when x approaching to a number, in that case, x equal to that number is the vertical symptom. And this little note with that. Right. So with that, I stop section 2.4 here. See you in another section in Calculus 1. As always, thank you for watching.